Question 2. So, nice quick question, this one, worth 4 marks. And this question is about electromagnetic waves. So, infrared and microwaves are two types of electromagnetic radiation. State one example of the use of each type of radiation for communication. Okay, the key word here is communication, because you can use infrared for heating, and you can use microwaves for heating food, which is most commonly the type of answer I would see when you get a question like this. However, this one specifically asks about communication. So infrared, in terms of communication, that's going to be remote controls. So infrared radiation, you press a remote control, you want to change the TV, that's going to send out an infrared ray, infrared wave, and that will communicate with your TV, and you can control it that way. You can't see it because it's not in the visible spectrum. And microwaves, again, don't write heating food. For communication, microwaves are what we use for mobile phones. And the reason we use them for mobile phones is because on the Earth, so you imagine this is the Earth, and then we've got this idea that that's a satellite. Believe me, that is definitely a satellite. There's this ring around the world, ring around the Earth, called the ionosphere. And the ionosphere will reflect radio waves, which is really useful if you're trying to bounce radio signals around. So if you want to bounce your radio signal around, that's really, really handy. But if you're just trying to get to that satellite, the problem is it might hit that ionosphere and bounce off it. So what we need to use a wave that can go through there. So we would use microwaves. So microwaves can go through this ionosphere. I'm just going to write that on. Ion, like ionosphere. So the ionosphere, the microwaves can go through, whereas radio waves can't. So for mobile phones or any type of satellite communication, we've got to use microwaves. Some of the properties of infrared and microwaves are the same. State 2 of these properties. Okay, so properties are like their characteristics. So they're both EM. That's not a property though, but them being electromagnetic means that they're going to share some of those things. So all electromagnetic waves travel at the same speed. They travel at the speed of sound, and they are all transverse. So we could have either of those. So we can say they travel at the same speed, which is the speed of light. In a vacuum. So once the light waves or any EM wave, comes into Earth's atmosphere, the waves are going to get slowed down by contacting with the gas particles, or particles in the air. But in a vacuum, like in space, all those waves will travel at the same speed because there aren't any particles there in order to collide with and get slowed down. So they all travel at the same speed. The fact that they're all waves, do similar things. So all waves can do this. They can bounce off things. We call that reflection. So all waves can be reflected. They can all be refracted. So the idea of, the wave comes in and it'll then change speed and go at a slightly different angle. So that is your refraction. So they can be reflected, they can be refracted, they can be diffracted, they can be absorbed, they can be transmitted. There's loads of things we could talk about in terms of the fact that they're a wave, but the one I'm going to say is they can both be reflected. Okay. All right, and that's the end of question 2.